Hello everyone, today we are going to solve the problem counting towers. Your task is to build a tower whose width is 2 and height is n. You have unlimited supply of blocks whose width and height are integers. For a given n, you have to calculate how many different towers you can build. Mirror and rotated towers are counted separately if they look different. Okay. So you have tower of height n and width is 2. You can put some blocks. You can put some blocks, right? And you have to tell that how many different towers you can build by putting that blocks. One thing you have to care about that if the towers initially look different, if after rotating they are similar, they counted separately, right? They counted separately. So what can you do initially, right? What can you do? You can put the block of width 2, right? Or you can put the block of width 1, right? You can do this. You could do this, right? Now you can choose any height from 1 to n. You can extend it to from 1 to 2, 3, 4 up to n, right? Similarly for this one, you can extend it right up to height n. Similarly for this, you can extend it up to height n, right? So there are many possible height or width that you can choose and put that block, and through this you can make different tasks, right? So there are some observations that I can make. There are some observations that you can choose a block of width 1, uh, block. You can choose a block of width 1 or 2, and you can extend it up to height n, right? These observations that I made, right? Now how can you extend? How can you extend? There are different cases. There are different cases that you extend it, right? You extend it, and you can close it. You can close it, right? If you're going to close it, then the next thing you can do that you can start with a block of width 1, or you can start with a block of width 2, right? So there are the next observation is this. The next observation is this. The first is that you can choose the width. You can choose the width of 1 or 2, or you can extend it. You can extend it. The second thing that you can close it and start with new blocks, and you can extend the block itself. You can extend the block itself, right? Now the next observation that I can make that uh, for this you can close it and you can start with the block width of 1, and you can close it, or you can start with the block of width 2, or that you can extend it, right? You can extend it. These are the possibilities if you put the block of width 2, right? Now for this there are again many observations that I can make that you can extend both of these. You can extend both of this, right? Or what you can do that you close one and extend the another one, right? For example, you close the left one and you extend the right one. You can close the right one and you extend the left, right? Or what you can do that you close the both of one and you start with a block of 2, and you start with a block of you can start with a block of you close it both and you start with a block of 2, right? These are the possible choices that you can make, right? Now let me summarize this observations. Let me summarize this. Let me summarize this. Let me summarize. There are two situations, right? There are two situations that you can the previous block, the ith for the ith row. The previous block is of width 1, right? And the previous block is of width 2, and you have to extend it. One more observation that you can make that if suppose you put the block of width 1 of width 1, right? you put the block of width 1, right? You put the block of width 1. So what, and the block, the right block, suppose, is of greater height, right? So can you put for the this row, for the this row, can you put the block of width 2? No. Why? Because there is for the I plus 1, there is already a block of width 1, right? So you can put only the block of width 1, right? So this is another observation that I can have, right? So by so let's look at the different cases that I can through which that I can extend, right? So if the previous block is of height is of width 1, what can you do? You can close the one of them and you start with the width of 1, and you can extend the right one, right? You can extend the right one. You did not close it, uh, and you extend it, right? The second thing you can do, that you extend the left one. You do not close it. You did not close it, and you close it the right one, and you extend another width of 1, right? If you extend the width of uh, if you extend the width of 1, you can put only the block of width 1 that we saw, right? If there is a block already, if there is a block already of width 1, you can extend only width of 2 of width 1, right? So the next thing you can do, that you close both of them. You close both of them and you start with a width of 1. You start with a width of 1. And another possible case, that you extend both the blocks. You did not close, right? You start with the extend. The next observation, that is, if you close it, that you have another choice, that you start with a width of 2, right? So these are the possible extension, right? If the previous block is of width 1. Now let's see if the previous block is of width 2, right? So what can you do? You can extend the block itself. You can extend the block itself, right? Or there is another possible situation, that you can close it, or you start with a width of 2. You close it and you start with a width of 1, right? So these are the possible observations. These are the observations that I can, right, that I made. So these are the observations. So with the help of these observations, let's try to write a transition states. Let's try to write the transition states. So let's try to write the transition states. Transition states, right? So so let's say what dp of I0 represents, right? Or dp I1 represents. This represents the block of width 1 try to extend, and the block of width 2 try to extend, right? This represents width 1. This represents width 2 try to extend, right? And what the whole thing represents, that the number of the number of tasks, the number of different tasks that you can build, the number of different tasks, the number of different tasks of length I to n minus 1, of length I to n minus 1, such that previous block of width 1 try to extend, right? This is what dpi of 0 represents. And for dpi I1, it represents the number of different uh, the number of different the number of different tasks of length I to n minus 1, such that previous block previous block of width 2 try to extend. This is something dp of I1 represent, and this is something that dp I0 represent, I0 represent, right? Now, how to write the transition? Now, what will be the transition, right? What will be the transition? So, for the block of width 1, if it is try to extend, so what is dp I0? dp of I0 is equals to the dp of I plus 1 0 for this, right? For this case, width of 1 width of 1 is try to extend, right? Similarly, plus here also the width of 1 is trying to extend. So for this, plus here also width of 1 trying to extend, plus here also width of 1 try to extend, right? But here width of 1 trying to extend, I plus 1, dp of I plus 1, and 1 for try to extend, the width of 2 try to extend, right? So it is the addition of all of this, right? So what I can say that dp of I0 is equal to is equal to dp is equal to 4 into dp of I plus 1 0 plus में dp of I plus 1 1, right? For 1, that is width of 1 trying to extend. So this is transition for dp I0. For dp I1, for dp I1, what will be the transition for dp I1, right? It will be dp of I plus 1, dp of I plus 1, and width of 2 try to extend, dp of I plus 1, width of 2 try to extend, with dp of I plus 1, d width of 1 try to extend. For this, the transition will be dp of I plus 1 and width of 2 try to extend, and dp of I plus 1 0. So this is the transition, right? This is the transition. Next thing, we have to write the base case, right? We have to write the base case. So there can be two possibilities. The first thing is that you try to extend. If you reach at the end, if you reach at the very end, right, then there is two possibility that you are trying to extend width of 1, right? Or there is another possibility that if you reach at the end, you try to extend width of 2, right? If you reach at the end, why you are going to extend, right? So you are going to close it. You are going to close it, both of the blocks, right? So there is only one possibility, that dp of n0 if width of 1 trying to extend and you reach at the end. So there is only one possible there is only one tower that you can build, right? There is only one tower that you can build, that's the tower itself. And for this, you can also build only one tower, right? If you reach at the very end, right? If you reach at the very end, so there is only one possibility, right? So this will be the base. This is the basis, right? This is the basis. So let's try to code it, right? I hope you understood how we did transitions, right? How we formulate it, right? How we formulate it, right? So let's try to code it. So let's try to code it. We have the t number of test cases, right? N length of tower, take the input, let's define the dp vector, type long, size n plus 1 close to, right? Then we have to define the base case, dp of n0 is equals to 1, dp of n1 equals to 1, correct? Then we have to traverse from I equals to n minus 1 to I greater than equal to 1, I minus minus, right? Then we have to do transition, right? First for the block of width 1, right? Block of width 1, and the second for the block of width 2, right? We saw that the transition is 4 into dp of I plus 1 if width of 1 try to extend, and there is another case that is dp of I plus 1 and width of 2 try to extend. The next transition is 2 into dp of I plus 1 if width of 2 try to extend, and there is another case for the width 1, right? and we have to do modulo with 10 to the power 9 plus 7. Right? We have to print the answer. Then we have to print the answer, that is C out dp of 1 0 plus में dp of 1 plus में dp of 1 right? And we have to take the do the modulo also here, right? So this will be the code, right? Now let me define here what dpi 0 or dpi 1 represents, that is, right, what it means that uh, is defined for dp 1, right? That is from 1 to n. From 1 to n, how many different towers can you build if block of width 1 try to extend? For this, how many different towers can you build if a width of 2 block of width 2 try to extend, right? So you have to add this, and this will be our final. So this is our final answer. So let's try to run it. Let me check once if there is any typo mistake or not. Yes, it is correct. Perfect. So let's try to run it. Yeah, it gives us the correct answer, right? Let's discuss the time complexity. The time complexity is n, right? The time complexity is n, right? Because the loop goes from n minus 1 to 1, that is n, right? And the space complexity is we are using 2 divisor of n plus 1 cross 2, right? So this is the code. I hope you understood.
Until we reach it, all you need to know is that we're holding on. We rise up.